Hello everybody and welcome back to the building blog for this Cirrus moth designed by David Bonington Sports. What we're going to look at today is a little bit of an update and the next steps that I'm going to take. I hope it's quite obvious there. The first biggest change that perhaps you can see are the addition of these false riblets all the way on the upper wing. Of course, it has to be repeated on the lower wing, and I anticipate that when this wing is covered and the lower wing's covered, that you'll see a ripple effect where they would be. And as I mentioned in the last video, they're by no means scale representations, but it's a caricature of a Cirrus moth is how I would describe it, and I think that really enhances the appearance along with the more scale-like upper tank. Other things that I've been busy with, and I'll show you those in a moment, I've actually fully installed all the radio gear internally in the fuselage that's going in. So that's the throttle, the rudder and the elevator servos are all installed in there, and I'll show you that in a little bit more detail. And I hope you can see, if I zoom in a little, I've also installed the extension cables into the lower wing ready to receive the aileron servos, which will go in here, and that once again will be a separate video. A word about the surface controls for the elevator and for the rudder. There we go. Now, when I was making this, one of the videos I've actually installed a pull-pull system for the rudder, and I think it looks really cool with the cables running down the outside of the fuselage, and I fully anticipated doing the same for the elevator with the cables just appearing down about here, and they run through a pulley or a hoop on the leading edge of the tail surface. However, when I've looked very closely at photographs of the prototype, which is GEBLV, the more I've looked, the less I've seen any evidence that they used a pull-pull system on the elevator as they have in many more Cirrus planes that I've seen. And I can only assume that at some stage that system has been replaced by a pushrod system. Now, that wouldn't necessarily be unheard of, because the SE5 that I built, it also had in the prototype a pushrod system for the elevator. It didn't operate a pull-pull system for the elevator, which was the norm at the time. So I'm just assuming, I may be wrong, that at some stage this Cirrus has been modified and has a pushrod rather than pull-pull. And that being the case, installing a pushrod system, which we're going to look at today, is a far easier option, to be quite honest with you. And I'm going to show you how I'm going to go about installing a pushrod system into this aircraft, so that I've got the control of the rudder and the elevator all completed, along with the throttle linkage. So the next thing we'll do is I'll open up and I'll take off the wings, and we'll have a look at the radio installation inside, and then we'll talk about how I'm going to go about putting this pushrod in. Here we have a little peek inside the fuselage. Before we look a little closer, could I ask you to consider subscribing if you haven't already done so? Lots of people pop in and repeatedly pop in but haven't subscribed. It costs nothing to do so, and if you do subscribe, you get pop-up alerts if you press the little bell icon to see on the latest videos, and that's always fun to follow. And I try to link these to playlists if you're only interested in this particular model. So let's have a closer look. What we have here, this servo here operates the pull-pull system for the rudder. And I was informed that actually I needn't have gone to all of this trouble. I was very keen on keeping the fulcrum points from here to here, and obviously the same on the other side, to match those on the rudder horn. But somebody informed me that actually that's not necessary, and it doesn't matter too much if one of the cables goes slack when the servos are operating, because the air actually pushes back and acts in resistance to the opposing cable, if that makes sense. But anyway, lesson learned, but I'm quite happy with that. It seems to work. This orange servo is an old Hobby King one, and that's going to operate the throttle. It's actually a geared metal one, so I'm not too concerned. I'm not put off by the term Hobby King here. And this servo that's set at an angle, I've had to do that because space is very tight because of these connecting rods here. I've turned it round at 90 degrees, and this is the servo that's going to operate the elevator. And actually, by dropping it about an inch or 3/4 of an inch, it actually lines up much better for the push rod that's going to run through and connect to the elevator. So what we're going to do today is make up a push rod. And I'll put this to one side. We'll just pause for a moment, and I'm going to show you how I'm going to go about doing that. The first thing I have to do is to take the clevis here, thread it onto the rod, and leave enough adjustment room on the rod itself. So I'm going to thread it on, and I'm going to take the threading about 1/4 of an inch inside. That allows me adjustment to take it out, but I've still got room that I can thread it in without it causing interference with the connecting end. So that's the first stage. The next thing I'm going to do, I'm going to use this dowel. You can actually use a 1/4 inch or maybe 3/16 balsa, but this is a dowel. It's not going to add significantly to the weight. I'm going to leave a little overlap, and then about an inch in, I'm going to make a bend at 90 degrees. So there we go. That I'll cut off in a second off camera. Next thing I'm going to do is to offer this up, mark and pencil approximately where it goes, and we're going to get that set up on this dowel. Now cut through, I'm ready to actually attach it to the dowel. So that's the mark there, excuse me, there. I'm going to drill right the way through, and then we're going to offer it up to the wire part of the connector. Trying not to go right through to my finger. Yeah, I have done that before, of course I have. I'm going to take it through. Be a lot quicker if I used the Dremel, but then I'd have to go and get it and connect it up, etc. This drill could do with sharpening as well, I think. I am going to get the Dremel, just bear with me. Correct tool for the job, here we go. Should have got that in the first place. So this should now go through, yes. Now what I always like to do with these is to cut a groove for the actual metal rod to sit in. So that's what I'm going to do now. I'm going to draw a line down. Down here. And then I'm going to cut into that. Cut a V out. and using a file, just going to open that out a little. Now hopefully that wire will sit into the groove, and it does. So that's now sitting in there, and what I'm going to do is bind it on, and for that I'm using this thread. It's just a heavy thread. I think it was actually used in bookbinding. So I'll cut a length off. I'm going to whip this on. I'm going to lay a length down, round, and then start the process of binding it on. Start that again because I want it a little bit tighter than that. Now I'm going to use epoxy smeared all over this. And I can guarantee that once I've done so, this will be the strongest part of the push rod. Chances are the push rod would snap before this would pull out. I'll actually just hold it in place with a little zap of super glue to stop the thread unwinding itself. But I'm actually going to use epoxy to sort of seal it all in. So I'm going to give a little zap of C here. Just to hold it in place. And that's the first, whoops, excuse me, that's the first part of the push rod done. Cut that off. That's the first part done. There you go. Nice and neat. If I'd wanted to, I could have chamfered it underneath as well, but that's quite adequate for the job. Now to the next stage. As I hope you can see, I've pushed the push rod through, and it goes through without having to resort to my hands coming in from the outside where the covering would be. We may have to adjust the length of that. The next thing to do is to actually open up the hole on the arm from the servo, because they always tend to be a little bit neat for that clevis. So I'm going to do that now. This will be by hand, because I think if you use a Dremel, it tends to rotate far too quickly, and all it does is melt the actual plastic, and then you end up with a hole in the clevis that's far too big, which is what we don't want. So I will do this by hand. I'm just going to take it in the second hole, I think. I'm going to do it on the other side as well. I'll tell you why in a second. Now I know that servo is centered with the radio gear because I have actually bound a receiver to it. But what you'll find is when you put this in one direction it'll be off-center, and the other direction it'll be at right angles. And you do want the geometry to be the same on the servo arm as it is on the actual horn end. So it's always a little bit awkward getting these things to open up and go on. That's it through. So the push rod will go there, and I'm going to take it. Just by chance I've hit the right way. If I put the arm the other way around, I can guarantee it to notch out. So I'm going to take it diagonally. Hope you can see that. A little bit dark in there. It doesn't like that. That's a little better. Diagonally from the right hand side, exiting on the left hand side of the fuselage. So we've got that in place. Now it's a case of doing the other end, and let's see how we're going to set that up. Here we go. We're at the business end now, and what I've actually done is I've taken a control horn and temporarily fitted it in place. Whether that's the one that stays there or whether I make a custom made one, I'm not sure yet, but it will allow me to set this up. So I'm going to hold this in place. You'll notice I've added the arm, line it up. I'm just going to mark on the position that I think I need to cut out a slot, a small slot. It's all a bit of a balancing act here. So I'm going with there. I'm going to cut a slot out in that position. Hope you can see that. I'm going to cut a slot out there and then feed the wire through and see if I can line it up with the dough. I hope you can see here that I've put a gentle curve and a bend here, and when I offer it up to the fuselage, hopefully you'll get the idea. This is going to allow me to bind it onto the push rod in a moment without any interference, like that. So I'll put a 90-degree bend in here to go back into the push rod as we did at the other end, and then I'll bind it on, and hopefully it'll run all the way through without binding at all on the sides or touching anything. Let's see what happens. And there we have it. That's the installation complete. The push rod's running all the way through. It's not fouling anywhere. It's a clear run, and although this is only pinned in place, there is no slop at all in the control surface, which is obviously what you're aiming for. You don't want to see it bouncing around and vibrating. I have actually, if you look closely, I've cut too much out for this slot, but I've actually kept the parts that came out, and I'll glue some back in to make the hole smaller. It doesn't need to be quite as big as that. But it wouldn't be the end of the world if I just left it as it was. So that's the installation. I'll take the push rod back out again. I'll epoxy the wire part into the dowel itself, and then that's the control surface is finished for this build. If you haven't gone down this route and made these yourself, I know sometimes even simple tasks can seem very daunting, and then you have a sort of eureka moment once you've seen them being done. I hope that's what I do in these videos. I don't claim to be an expert by any means, but I have got a lot of experience of model making, and I've pinched the best ideas off everybody I come across. I call that good research, and you're more than welcome to try anything that I've done. But please have a go at doing some building. The hobby's a great hobby. It isn't just about the flying, it's also about the being creative and the thrill of making something and seeing it fly. So thanks for watching. Give it a thumbs up if you've enjoyed it. Take care.